Okay, continuing on, we now have yet another RPO sequence in our Astrogator RPO series videos for these sequences. In this case, we're looking at another forced motion sequence. This is the hop and stop sequence. And so we have that here in our MCS, just added to our default RPO satellite that gets loaded in when we load in the objects. Our parameters are here. And so in this case, the hop and stop RPO sequence is, again, it does a single maneuver to start the hop, and it moves between relative positions, starting where we start and ending where we specify. And then it stops all relative motion. The sequence hops from the current position to the new position, and at the end of the hop, the relative motion to the target, we set it to 0, or we stop it such that it is. It's accomplished by a maneuver at the beginning to initiate the transfer, and then a second maneuver at the desired final relative position and transfer time. So we're going to show an example here where we transfer from a negative 1,000 meters along the V-bar to a final position of 500 meters on the R-bar, and we do this in 2 hours. You can compare this with our hop sequence video, as well as the hop min DV sequence, and each of them are a little bit different in a different way. In this case, we're going to get there in 2 hours, and so we just go ahead and run this, and we actually had already converged here, so it's good that it reconverges, of course. Let's set our animation time to the beginning of the hop and stop sequence, and zoom in the 3D graphics window to our RPO satellite. And if we kind of back out a little bit, we kind of see where we start. Negative 1,000 meters or a kilometer, negative 1 kilometer on the V-bar, so behind the target satellite. And we want to end up at 500 meters on the R-bar. And so let's go ahead and just play that out. And moving fairly quickly there in 2 hours. And it takes us to plus 500 meters along the R-bar. So that is the hop and stop RPO sequence. So this is the one that you would want to use if you want to stop motion at the end. And to do that in an optimal time, you would start with the hop min DV sequence, get the time from that, and then give that to this hop and stop sequence. All right, so thank you for listening.